Welcome back. I'm Jennifer from Jester Safety Resources. In this tutorial, we will review what a risk management plan is and who's required to have one. Next, we'll outline the different components required to be in your plan. However, our main focus today will be on creating the threat zones using ALOHA and MARPLOT software and including those into your document. What is a risk management plan? The purpose of the California Accidental Release Prevention or CalARP program is to prevent accidental releases of substances that can cause serious harm to the public and the environment, to minimize the damage if releases do occur, and to satisfy community right to know laws. This is accomplished by requiring businesses that produce, handle, process, distribute, or store certain chemicals over a threshold quantity to develop a risk management program, prepare a risk management plan or RMP, and then submit that plan to your local certified unified program agency. Who is covered? Any business that has more than a threshold quantity of a regulated substance in a process is covered. Regulated substances are those chemicals that are either on the federal list, which is Title 40 of the Code of Federal Regulations, Substandard 68.130, or the state list, which is Title 22 of the California Code of Regulations, Substandard 2770.5. New and modified businesses which exceed the threshold quantity of a regulated substance must complete an RMP before operations commence, some with deadlines well in advance of the actual operation. Early coordination with your CUPA can be critical for smooth startup. Any new or modified business which is required to prepare an RMP must certify whether an upcoming project will contain more than a threshold quantity of a regulated substance in the process or a source or modified source of hazardous air emissions. Once you've decided that your facility does have one or more processes that apply to the CalARP regulation, you need to identify what actions you must take to be in compliance. There are different requirements based on the potential for public impact and also the level of effort that would be needed to prevent accidents. The CalARP regulation has set 3 levels of requirements that apply to covered processes, and those are programs 1 through 3. For the purposes of this tutorial, we're only going to focus on program level 2, which include processes that kind of fall in the middle of the road. We're going to assume that there would be potential risk to the community. However, it doesn't involve the most complex chemical processes or catastrophic off-site consequences. Components of the plan. The RMP must also consider the proximity to sensitive populations located in schools, residential areas, general acute care hospitals, long-term healthcare facilities, and child daycare facilities. Another requirement component for the RMP is to consider external events such as seismic activity. There are 3 program levels depending on this type of business, potential impact, accident history, among other factors. Components of your plan include safety information, hazard review, operating procedures, training requirements, maintenance requirements, compliance audits, and incident investigation. It's also important to remember that facilities are required to submit revised RMPs every 5 years after their initial submission. A big component of your RMP will be to generate threat zones under various scenarios. But before you can do that, I recommend going to the EPA website at www.epa.gov and go to the Cameo, which is Computer Aided Management of Emergency Operations page. Once there, you can use the links provided to download 2 programs that you'll need to accomplish your RMP. The first is called ALOHA. This stands for Aerial Locations of Hazardous Atmospheres, and this is used widely to plan for and respond to chemical emergencies. The second program you'll need to go along with ALOHA is called MARPLOT. This is the mapping application for response planning and local operational tasks. This is used to plan for and respond to chemical emergencies. Worst case scenarios. You will have to define a worst case release, which is usually the loss of the total contents of your largest vessel. This worst case release scenario for this tutorial is going to involve anhydrous ammonia resulting from a catastrophic failure. I'll set up a release of approximately 2,000 pounds, which is the maximum amount our unit would be capable of holding, and it will be released to a pool where vaporization will occur in 10 minutes with no passive mitigation system considered. The first step is to open your ALOHA program and enter the site data about your facility. There are only 3 parts to this and are the following. Location. I'm going to use Fresno, California for the example today. Building air exchanges per hour. I selected 0.53 for a sheltered single-story building. And time. So unless you overwrite it, the program will default to the internal computer clock at the time that you're generating your report. Now let's take a look at how you enter this data into ALOHA. So we're going to start with location information. You're going to click on the site data and select location. Then find the city and state your facility is located in within the drop-down menu and choose the select button. So for this example, I've selected Fresno, California. Go back into the site data and click Building Type. In the Infiltration Building Parameters dialog box, select your building type and whether it's sheltered or unsheltered, and then click OK. A quick definition for the air exchange rate. It's the number of times that the outdoor air replaces the indoor air and is usually expressed as the number of air changes per hour. Go to the site data one more time and click Date and Time. The date and time default is set on the internal clock. In other words, this is the date and time that you're actually generating your report. I always keep the default setting. The next section that ALOHA will ask for is your chemical information. This is the data that will be generated for the chemical you enter into ALOHA and can all be located on a safety data sheet. However, that same data will also generate in ALOHA automatically once you've selected the chemical. The items that will automatically be included on your ALOHA text summary include the chemical name, molecular weight, the AEGL 1, 2, and 3, IDLH, LEL, UEL, ambient boiling point, vapor pressure at ambient temperature, and ambient saturated concentration. For the sake of familiarity, let's look at some of the terms used in this section. AEGL. This is an acronym for Acute Exposure Guideline Levels. According to the EPA, AEGLs are used as guidance when rare or usually accidental releases of chemicals happen into the air. The AEGLs are expressed as specific concentrations of airborne chemicals at which health effects could occur. IDLH is an acronym that stands for Immediately Dangerous to Life and Health. This is a limit that was originally established by NIOSH for selecting workplace respirators. A chemical's IDLH represents the maximum concentration in the air to which a healthy adult worker could be exposed without suffering permanent or escape-impairing health effects. LEL means lower explosive limit, or it's also referred to as the lower flammable limit of a vapor or gas. This is the lowest concentration or lowest percentage of the substance in the air that would produce a flash of fire when an ignition source such as heat, arc, or flame is present. UEL is the upper explosive limit, and it's also called the upper flammable limit or UFL. Whichever you refer to it as, it's the highest concentration of a gas above which it won't ignite. In other words, the concentrations higher than UELs are considered to be too rich to burn. Ambient boiling point is when the boiling point of a liquid depends on temperature, atmospheric pressure, and the vapor pressure of a liquid. Vapor pressure is just a property of liquid. Ambient saturation concentration is the maximum concentration of vapor that could be attained in the air in a closed space above a liquid at ambient temperature and pressure. So if a spilled liquid has a high ambient saturation concentration, that means it has a strong ability to displace the air, and the concentration of vapor in the air above it will be high. So if it has a low ambient saturation concentration, the vapor concentration will be low. The next step is to add your chemical. Go to Setup and click on Chemical. From the dialog box, choose whether you're entering a pure chemical or a solution, and then select your chemical from the drop-down menu. Since I've chosen anhydrous ammonia for this tutorial, I've selected ammonia from the list. Once you've selected the chemical, ALOHA will automatically enter the chemical data for you into the summary page, which will continue to build as you enter more information. Next, we'll focus on entering the atmospheric data. The data that you will need to provide includes the following: wind speed, direction, and height, ground roughness, cloud cover, air temperature, stability class, inversion height, and relative humidity. Now we'll enter information about the potential atmospheric conditions at the facility during a release. But first, let's take a closer look at a couple of the terms. Atmospheric stability, or stability class, is a measure of the tendency of air to move upward or downward within the atmosphere, generating turbulence. There are 6 atmospheric stability classes from A to F, each representing a different degree of turbulence in the atmosphere. A represents the most unstable conditions, meaning air has a strong tendency to move up or down and the atmosphere is more turbulent. And F represents the most stable conditions, meaning the air has little tendency to be displaced up or down and the atmosphere is less turbulent. The next term is inversion. This is an atmospheric condition in which an unstable layer of air near the ground lies beneath a very stable layer of air above. The height of the abrupt change of atmospheric stability is called the inversion height. An inversion can actually trap pollutant gases below the inversion height, and this causes ground level concentrations of a pollutant to reach higher levels than would otherwise be expected. Now we'll enter the atmospheric data. Go back to Setup and then click Atmospheric, then User Input from the drop-down menu. Once you've clicked User Input, a dialog box will appear called Atmospheric Options. I've entered wind speed at 1.5 meters per second coming from the northwest with an above-ground measurement height at 3 meters. I set ground roughness as open country with 0% cloud cover. Once you've entered the last part of the atmospheric data and click OK, a second dialog box appears. I set the air temperature at 108 degrees Fahrenheit and used a manual override to set the stability class to F. Next, I entered that there is no inversion present. Atmospheric inversions, remember, are layers in the atmosphere where the temperature increases with height. And then lastly, I set the humidity at 50%. The next part that needs to be entered is the source strength, which includes the following terms: direct source, release duration, release rate, and total amount released. Now that we know what information needs to be included, let's quickly review a couple of the terms. Direct source. You will choose this option when you know or can estimate either the amount of gas being released or its rate of entry. Release duration. This is the period of time over which a release occurs. ALOHA limits the release duration to 1 hour. Release rate. This is the rate at which a chemical is released into the atmosphere. And total amount released. This is just the release rate multiplied by the release duration. For example, here the release rate is set at 200 pounds per minute for 10 minutes. So you take 200, multiply by 10, that equals 2,000 total pounds released. You'll use ALOHA to predict the movement and dispersion of a gas in the atmosphere. Go to Setup in the top toolbar and click Source and then Direct. By choosing Direct Source, it means that the release goes directly into the atmosphere. I've then selected the volume to be measured in pounds and chose Continuous Source. As a reminder, a continuous source releases gas into the atmosphere at a constant rate for an extended period of time, whereas an instantaneous source represents more of a burst and a very short-term release. In fact, ALOHA assumes that an instantaneous release lasts only 1 minute. For this example, when using anhydrous ammonia, a separate dialog box will appear warning of the potential of a flash boil, which is a sudden vaporization of a liquid stored under pressure. This sudden pressure reduction superheats the material, causing it to flash boil as it leaves the container in a two-phase flow. That means that the chemical is escaping the container as both a liquid and a gas, normally in the form of an aerosol. To set the type of dispersion we'll be looking at, go back to the top of the page and click Setup again, then Calculation Options. Select Heavy Gas Dispersion only to start with, and then click OK. Heavy gas means that a gas cloud is denser than the air around it, and dispersion is just the process by which a cloud of pollutant gas spreads out into the atmosphere, mixing with the air and then eventually becoming diluted to below hazardous levels. Now we're ready to move on to Display. Navigating back to the toolbar, find and select Display and then Threat Zone. Because this example uses anhydrous ammonia, I chose Toxic Area of Vapor Cloud and clicked OK. A new dialog box should appear asking you to select the toxic level of concern. Open the drop-down menu for the Red Threat Zone LOC, or Level of Concern. A level of concern is defined as a threshold concentration of an airborne pollutant that's normally at a level that would be hazardous to people or property. So whenever you use ALOHA to analyze a chemical release scenario, you must choose one or more LOCs. I've chosen ERPG3 at 1500 ppm. ERPG, or Emergency Response Planning Guidelines, are guidelines used to anticipate human adverse health effects that are caused by exposure to that toxic chemical. For the Orange Threat Zone LOC, I chose the user-specified option and typed 0.14 milligrams per liter because that's the toxic endpoint for anhydrous ammonia. And finally, for the Yellow Threat Zone LOC, I selected None. At the bottom of this dialog box, it asks about wind direction confidence lines. I've chosen to keep the default selection for only the longest threat zones. ALOHA will now generate a threat zone graph in miles for the worst case scenario for heavy gas dispersion. I recommend copying and pasting or using a cropped screenshot of this graph to include as part of your RMP. Print your text summary as a PDF and then import that into your RMP, or you can crop a screenshot of your worst case heavy gas scenario text summary from ALOHA as a reference to show where your data came from. Now that you've gotten a copy of your text summary and graph, you'll need to plot it onto a map of the area where the facility is physically located. This will be accomplished by using MARPLOT. On your top toolbar, select Sharing and click MARPLOT and then Go to Map. When the MARPLOT program opens, notice that at the top toolbar there's an ALOHA drop-down option. Click the ALOHA area to activate that drop-down. You'll be given two options. You can choose to set either the source point or the threat point. I'll be selecting the source point button and then clicking the facility location on the map as a source of the potential release. Remember when you entered facility information into ALOHA at the beginning? Well, that same city information has now been transferred to your MARPLOT map. You can zoom in or out of the map to find the exact location of your facility and then click there. Be sure to use the expandable toolbar on the right side of the screen to choose Google Street Maps in order to be able to view your commercial locations. I also want to take this time to quickly point out that I've chosen the location for this tutorial randomly, and I'm in no way meaning to imply that there would be a release in this area. This is only an example to show how to navigate ALOHA and MARPLOT for the purposes of putting together your RMP. Okay, do you remember when we generated our heavy gas dispersion model in ALOHA? I hope so, because it's going to come back into play right now. MARPLOT has now taken that same model and placed it at the source point that we chose on the map. Now you can see all the areas, businesses, residences, and even the population that falls within your threat zone. The closer you zoom in, the more information can be viewed on your map. Next, I'll show you how to access some of this information for your report. Start by choosing the circular selection tool, since the parameter around the source point will be observed as a diameter, with the source point serving as the middle radius. After selecting the circle tool, click the center of the source point where the pink or purple cross is, and drag the circle tool out until it matches the perimeter of your threat zone. You can see that by dragging the edge of the circle selector, you can make it fit the curvature of the threat zone that's already been established. This creates a full circle. Everything that falls under the umbrella of this circle would be located within the threat zone and would be potentially affected in the event of a release. Also, now that the threat zone has been identified, you can obtain the population within that area by opening the drop-down menu in the upper toolbar and clicking on the Get Population USA. Once you've done this, the area will turn a shade of red and will show the radius, perimeter, and area of the threat zone. It also shows the population within the selected area and residential units located there as well. In addition, you're also required to identify public receptors that are located within that threat zone. Public receptors include off-site residences, institutions such as schools, child care centers, prisons, and hospitals. It also includes industrial, commercial, and office buildings, parks, or recreational areas that could be occupied by the public, where they may be exposed to concentrations of toxic chemicals, radiant heat, overpressure, just as a result of an accidental release from your facility. And basically, off-site means areas beyond your property boundary where the public has routine and unrestricted access during or outside of business hours. Roads and parking lots, though, are not usually included in the definition of public receptor, and in general, farmland also would not be considered a public receptor. If you're in doubt about whether to consider certain areas around your facility as public receptors, you should consult with your local CUPA. Using the MARPLOT Google Map, zoom in to view all of the sections of your threat zone one area at a time in order to identify and record all public receptors by name. You'll list those along with their street addresses and phone numbers on your RMP under the heading Worst Case Release Heavy Gas Scenario Receptors. You'll have to Google these establishments for that specific location information, as you won't be able to pull all that you need from the map. Exit MARPLOT and go back to ALOHA to run the worst-case scenario Gaussian dispersion model. While still retaining the previous facility, chemical, atmospheric, and source information in ALOHA, go back to Setup and select Source. Then choose Use Gaussian Dispersion Only. A Gaussian curve is just a bell-shaped or normal probability curve. ALOHA uses a Gaussian distribution to describe the movement and spreading of a gas that's neutrally buoyant, which means about as dense as air. We'll run both heavy gas and Gaussian scenarios today. Once you've selected the Gaussian dispersion, choose the toxic area of vapor cloud the same way we did for heavy gas dispersion scenarios. And again, the toxic levels of concern will remain the same for Gaussian as they were for our heavy gas dispersion. Once the LOCs have all been selected, save copies of both the toxic threat zone chart along with the ALOHA text summary the same way that we did before. Be sure to label your files carefully though, because confusion later about which is which, whether it's heavy gas or Gaussian, may result in you having to run the numbers again from scratch, and who has time for that? And again, just as a reminder, for the ALOHA text summaries, I normally choose a print to PDF and then save and rename that file. You'll get a cleaner look than if you just print and scan. Now you're ready to go back to the ALOHA Sharing tab on the upper toolbar to select MARPLOT and go to Map in order to overlay your Gaussian threat zone over your street map. We'll repeat the steps I showed you previously for the heavy gas scenario. Set your source point and create your perimeter with the circle selector. Then use the Get Population option and record those numbers with a screenshot. Start zooming in on the Google Street Map in order to see what public receptors fall within your threat zone area. List those along with your street addresses and phone numbers on your RMP under the heading Worst Case Release, Gaussian Scenario Receptors. Now that we've completed the worst case scenarios in heavy gas and Gaussian, it's time to run a new threat zone for alternative release scenarios. Exit MARPLOT and go back to ALOHA so we can change some data. Let's go. This alternative release scenario for anhydrous ammonia involves the release of 300 pounds of vapor from a valve that's repaired within 30 minutes. No passive mitigation was assumed, and control is reached by means of a manual shutdown of the system. And like before, here is the alternative atmospheric conditions represented in ALOHA. For the alternative scenario, I've changed the direct source and release duration from 200 pounds per minute for 10 minutes to 10 pounds per minute for 30 minutes. The release rate will change from 200 pounds per minute to 10 minutes per minute, which will change the total amount released from 2,000 pounds to 300 pounds. And here's that new information represented in ALOHA. Under the Setup Calculation option, select Use Heavy Gas Dispersion Only and click OK. Go to Display in the toolbar and select Threat Zone. Then I've selected Toxic Area of Vapor Cloud. Save copies of both the text summary and the charted Heavy Gas Threat Zone chart. And here's the alternative Heavy Gas Dispersion ALOHA text summary sample that yours should look close to once you generate yours with whatever chemical you've run through ALOHA, and then save your copy. Share the graph to MARPLOT map from ALOHA. Use the circle selector to outline your threat zone perimeter and determine your population numbers as we did before. Zoom in and record the names of any public receptors within your threat zone. Exit MARPLOT and go back to ALOHA one last time to create an alternative Gaussian dispersion scenario, keeping all of your previous data the same, with the exception of selecting the Gaussian dispersion calculation option. Generate your text summary and threat zone graph, and be sure to save both for later. Share your graph to the MARPLOT map again. Determine your population and residence numbers as well as public receptors. And folks, we've gotten through our heavy gas and Gaussian worst case and alternative case dispersion scenarios in ALOHA and MARPLOT. Those can go into your RMP and you can go from there. This was probably one of the most challenging parts for me when I first started out, and I'm really hoping that you were able to find some values in these tips and tutorials. If you found this helpful, please be sure to like, subscribe, and share. And if you'd like to get a template for your risk management plan, you can find that at Jester Safety Resources website. That's www.paperjester.com to get your copy today. Thank you so much for joining me, and I will see you next week for the next installment. Take care, my friends.